So today we will start from yesterday's homework problem. Okay. So in this problem, there is a given a random sample of size n from normal with mean mu and variance sigma naught square distribution. Construct most powerful test for testing h naught mu equal to mu naught versus h1 mu equal to mu 1, where mu 1 is less than mu naught, right? Here mu 1 is less than mu naught. So it's similar like the last problem. That is, you want to write the likelihood under h0 and h1, and we know that we reject h0 for large ratio, right? That is here in the problem is given that a random sample of size n, right? So we have to take the likelihood, that is likelihood under h1 divided by likelihood under h0, which is greater than k1. There is a rejection region here, right? So that then we have to substitute the value of likelihood functions. Then here this term got cancelled, so I'm simply write the remaining terms here. Okay, then simplify the terms like the similar problem. Then we can take a log on both sides. Then here, okay, so we need to find out for a function of a random variable, right? For that we have to simplify this term like divide by, we want only the function of random variable. Here we know that function of random variable is summation xi, right? So we need only these term. For that we have to uh, divide by minus 2 mu1 minus mu naught. That is, here we know that mu1 is less than mu naught, which means mu1 minus mu naught is less than 0, which is this is a negative term, right? So this is a negative term. Negative into negative is positive, right? Then we have to divide by this term. That means divide by this is a positive term, right? This is a positive term. Negative, negative. Then if we divide this term by here, then you can get summation xi same, right? Less than k divided by this term, right? Here not any changes in the sign. That means which implies that summation xi is less than k. Using that, we have to construct the most powerful test. That is phi of summation xi equal to 1 if summation xi less than k, 0 otherwise. Then similarly, we have to find out the critical value k using size condition. Like this, here x follows normal, so summation xi follows normal with the n mu n sigma naught square distribution, right? Then we have to transform normal variable into standard normal. Here less than sign, right? So we make it as a greater than. So for that, 1 minus probability of z greater equal to that term equal to alpha. Then we can get k value, right? Here that is z 1 minus alpha. Here 1 minus alpha, right? Then z 1 minus alpha. Then after finding the value of k, then we have to find out the power of the test. Similarly, here we make this summation xi term as a standard normal. That is the value random variable minus its mean divided by standard variable, standard deviation, right? Then you can go to here. The power of the test is 1 minus probability of z is greater equal to the k value minus n mu 1 divided by square root of n sigma naught square, right? Then we'll go for the next problem. That is given a random sample of size n from exponential with the 1 by theta distribution. Construct most powerful for testing h naught theta equal to theta naught versus h1 theta equal to theta 1, where theta 1 is greater than 0. So here we know that x follows exponential 1 by theta distribution, right? Under h naught x follows exponential with the 1 by here under h naught theta equal to theta naught, right? That is theta naught. Then under h1, x follows exponential with the 1 by, here under h1 theta equal to theta 1, right? That is under h0, sorry, h1, x follows exponential with the 1 by theta 1, right? So from Neyman-Pearson lemma, we know that we reject h0 for the large ratio. That is in here is a random sample of size n, right? So we have to take the likelihood function of that. There is a likelihood under h1, right? It is 1 by theta 1 x1 so on xn divided by likelihood under h0 is 1 by theta naught x1 x2 so on xn is greater than k. Okay, so we reject h0 for the large ratio, right? So here what is the likelihood under 1 by theta naught theta 1, that is a likelihood under h1. What is the density of exponential 1 by theta? What is the density? If x follows exponential 1 by theta, then what is the density? F of x theta equal to 1 by theta e power minus x by theta, right? Where x is greater equal to 0, theta is greater than 0, right? This is the density of exponential with 1 by theta, right? Then here what is our likelihood? Here likelihood under h1, that is the likelihood 1 by theta 1 x1 x2 so on xn equal to 1 by the product of fx comma the product of x that is here, that the product of I from 1 to n, product I 1 to n f xi theta 1, right? Theta 1 by theta 1, right? Here parameter is 1 by theta, is 1 by theta 1. That is the likelihood of 1 by theta 1 x1 x2 so on xn equal to product I from 1 to n 1 by theta 1 e power minus xi divided by theta 1, right? Is equal to 1 by theta 1 power n, right? Then e power minus product of e power minus summation xi, right? That is e power 1 by e power summation I1 to n xi divided by theta 1, right? Similarly, what is a likelihood under h0, that is likelihood 1 by theta naught x1 x2 so on xn equal to product I1 to n 1 by theta naught, right? Theta naught e power minus xi divided by theta naught is equal to 1 by theta naught power n e power minus summation xi divided by theta naught, right? I1 to n, right? Then we have to find out the rejection region using this likelihood function, right? It is a rejection region, which implies we know that what is the rejection region? Likelihood under h0, likelihood under h1 divided by likelihood under h0 greater than k value, right? That is here what is likelihood under h1? This value, right? Is 1 by theta 1 power n e power minus summation xi divided by theta 1 divided by likelihood under h0, that is 1 by theta naught power n e power minus summation xi divided by theta naught, which is greater than k1. Okay, then we will simplify this term. Then we want to get a function of a random variable, right, which is greater than some k value. So we have to simplify this term to get the rejection region. Okay, so here which implies that So we can write this term as here 1 by theta 1 power n divided by 1 by theta naught power n, right? Then we can write this term as theta naught divided by theta 1 power n, right? Into e power minus, so here e power minus summation xi divided by theta 1, and here divided by e power minus summation xi by theta naught, right? Here we can take these two terms together, right? It's e power minus summation xi I 1 to n into, it is 1 by theta 1, this term minus then this term, that is 1 by theta naught, right, which is greater than k1. Then which implies that theta naught divided by theta 1 power n e power minus summation I 1 to n xi 1 by theta 1 divided minus 1 by theta naught greater than k1. Same, right? Then we'll take we want only the function of random variable, right? That is you can simplify this term as minus summation xi I 1 to n 1 by theta 1 minus 1 by theta naught is greater than we divide by same term. Then here k2, that is, what is k2 then? It is k2 equal to k1 divided by this term, right? It is theta naught divided by theta 1 power n, right? Here multiply by, that means after this here multiply by this term. Here that is, it implies theta naught divided by theta 1 power n, same, right? Then you multiply by theta 1 divided by theta naught power n, then this term got cancelled, right? Then here also we have to multiply that term, right? That is theta 1 divided by theta naught power n, so that is k2 here, understood? Then we will take log on both sides, take log on both sides, which implies minus summation I 1 to n xi 1 to n xi into 1 by theta 1 minus 1 by theta naught, which is greater than k3, right? What is k3 then? K3 equal to log k2, right? Then which implies here we know that from the question is given that theta 1 is greater than theta naught, right? Then what is 1 by theta 1 1 by theta naught, which is, what is the relation between that? Which is here theta 1 is greater than theta naught, right? Then the reciprocal of that term is less than, right? If theta 1 is greater than theta naught, then 1 by theta 1 is less than 1 by theta naught, right? Then what is 1 by theta 1 minus 1 by theta naught is less than 0, right? Then here is a less than 0, it's a negative term, right? Then here also we have one negative term, right? The negative positive, that is summation I 1 to n xi minus this minus into this term, that is 1 by theta 1 1 by theta naught greater than k3. Here this is a negative term, right? It is less than 0, and here also negative, that is, then this become positive, right? Then we have to divide by that term itself, because we want to get a function of a random variable, right? Which implies summation I 1 to n xi is greater than k3 divided by this term. Okay, it is 1 by theta 1 minus 1 by theta naught, right? 1 by theta 1 minus 1 by theta 1. There is no sign change because here minus, right, and also these term is minus, negative, then negative negative got positive, right. Then dividing by the positive term, the sign remains not change, right. Then which implies summation I 1 to n xi is greater than k, right. That is a rejection region. What is k there? K equal to k3 divided by minus 1 by theta 1 minus 1 by theta naught, right. This is k term. Then here we got the rejection region, right. That is here is a function of random, it's a function of random variable, right. Then we have to write the most powerful test for testing. Therefore, most powerful test for testing h naught versus h1 is phi of the function of random variable, that is summation xi here, right. That is phi of summation I 1 to n xi, that is equal to 1 if summation xi is greater than k, 0 otherwise. Here we got the most powerful test for testing h0 versus h1, right. Then here we want to determine the k value, right, the critical value, by using size test, size of the test, right. That is to determine k, to determine k, we have to use the size test, size of the test, that is the expectation of phi of summation xi equal to alpha, right. Here which implies that the probability of summation xi which is greater than k equal to alpha, right. And we know that if x follows exponential 1 by theta, then 2 into summation xi divided by 1 by theta is follows 1 by theta is follows, if x follows exponential 1 by theta, then 2 into summation xi divided by theta is follows k square with 2 degrees of freedom, right. X follows exponential 1 by theta, then 2 into summation xi divided by theta follows chi square with 2 degrees of freedom, right. Then here we make the transformation of that variable, random variable, that means the probability of 2 into summation I 1 to n xi divided by theta not here, the size under null hypothesis, right. That is theta naught, right. It's greater than 2 into k divided by theta naught, which is equal to alpha, right. Which implies the probability of, here this is a chi-square term, right. That is chi-square 2n, which is greater than 2 into k divided by theta naught, which is equal to alpha, right. Then which implies, what is the k value then? It is 2k divided by theta naught equal to chi-square 2n comma alpha degrees of freedom, right. Which implies the k equal to chi-square 2n comma alpha into theta naught divided by 2, right. This is the k value of, this is a k value in this test. So here it is the most powerful test, right. So we have to find out what is the value of power of the test. It is power of the test, it's the power of the test formula, expectation of phi of summation xi under alternative hypothesis, right. That is the probability of, in this case, a probability of summation I 1 to n xi, which is greater than k, right, under alternative hypothesis. So which is equal to probability of So here also is a 2 into summation xi divided by theta follows of chi square with the 2 n degrees of freedom, right? So it make the transformation there. It is chi square 2n is greater than 2k divided by here theta 1 because it's under h1, right? It's equal to probability of chi square 2n greater than 2k divided by theta 1, right? It's equal to probability of chi square 2n. We know the value of is greater than 2 into what is the value k? K is chi square 2n alpha into theta naught divided by 2, right? And the whole divided by theta 1, right here. And here 2 could cancel, right? Which equal to probability of chi square 2n greater than theta naught divided by theta 1 into chi square 2n alpha degrees of freedom. This is the power of the test for this problem. Okay. Next, one homework problem. That is the same problem here. Case 2. That means in that problem in here theta 1 is less than theta naught. Okay, this is your homework problem. You should have to work out that.